So in this session I am going to explain the attenuators of Model 2 for microwaves and antenna subject, and it covers the course outcome CO2. Then in this session we are going to discuss about the introduction of attenuators, fixed type of attenuators, variable type of attenuators, flap attenuators, and movable one-way attenuators, and some questionnaires. First, I am going to explain the introduction about the attenuator. First, we will discuss what is attenuator. An attenuator is an electronic device that reduces the power of signal appreciably, distorting its waveform. And an attenuator is effectively the opposite of an amplifier through the two work by different methods. While amplifier provides the gain and attenuator provides the loss or gain less than 1. And attenuators are usually passive devices made from simple voltage divider networks used to control the amount of microwaves power transferred from one point to the another point, and reflects and absorbs the energy in some of the dissipative elements. And attenuation is a function of frequency. Then there are two types of attenuators. One is fixed type of attenuators and second one is variable type of attenuators. Variable type of attenuators again considering two waveguides, rectangular waveguides and the circular waveguides. If it is rectangular waveguides, then it is considered as one-way attenuators and the flap type attenuators. And if you are considering circular waveguide, then it is a rotary type of attenuators. First we will discuss about the fixed type of attenuators. The fixed type of attenuators are used to lower voltage, dissipate power, and improve the impedance matching. The fixed type of attenuators are commonly used where a fixed amount of power is to be provided. If such type of attenuators absorbs all the energy entering into it, we call it as a waveguide terminator. Then this namely consists of short section of waveguide with the tapered plug of absorbing material at the end. The tapering is done for providing a gradual transition from the waveguide medium to the absorbing medium, thus reducing the reflections occurring at the media applications, and dielectric is used in the class. Then this figure shows the coaxial line fixed attenuator, and this is a coaxial line, and this mid part is lossy material in the center conductor. And some of the performance characteristics of fixed attenuators are: first one, input and output impedance and flatness with the frequency, that is second one. Third one, average and peak power handling capability, and fourth one, temperature dependence. Second one is variable attenuator. So variable attenuator provides the continuous or stepwise variable attenuation. For rectangular waveguides, these attenuators can be flap type attenuator or one-way type attenuators. For circular waveguide, rotary type of attenuator can be used. Then first one, that is flap attenuator. The flap attenuator consists of resistive element or disc inserted into a longitudinal slot but are cut along the center of the wider dimension of the guide, which is responsible for attenuation. The degree of attenuation can be determined by depth if assertion. Flap is mounted on the hinged arm, allowing it to descend into the center of the waveguide. Then figure shows the flap attenuator, which is also a variable attenuator. A semicircular flap made up of lossy dielectric is made to descend into the longitudinal slot cut at the center of the top wall of the rectangular waveguide. When the flap is completely outside the slot, then the attenuation is 0, and when it is completely inside, the attenuation is maximum. Then the maximum direction of 90 dB attenuation is possible with this attenuator with the VSWR value is 1.05. The figure shows the flat attenuator. Here this point is called as longitudinal slot, and this is called as hinged arm, and this is called as lossy dielectric flap. Then the precision type of variable attenuator, that is consists of rectangular to circular transition, that is RCT, a piece of circular waveguide, that is CW, and circular to rectangular transition, that is CRT, as shown in this figure. Here this it is CRT, it is CW, and RCT. So in this figure we are using the R, RA and RB. These are called as resistive cords. Resistive cords R, RA, RB are placed inside this section. See, here it is R, RA, RB and RC. Okay. So a TE10 mode. So the center circular section containing the resistive cord RB can be precisely rotated by 360 degree with respect to the two fixed resistive cords. The induced current on the resistive cord R due to the incident signal is dissipated as heat producing attenuation of the transmitted signal. Then the TE mode in the RCT is, see, TE mode, TE10 mode, TE11 mode and TE10 mode. Both sides TE10 mode is there, in middle part that is TE11 mode is there. So TE mode in RCT is converted into TE in circular waveguide. The resistive cords R and RA kept perpendicular to the electric field of TE10 mode so that it does not absorb the energy, but any component parallel to its plane will be readily absorbed. Then second one is mobile 1A attenuator. The 1A position at the center of guide can be moved laterally from center, where it provides the maximum attenuation to the edge, where the attenuation is considerably reduced since the E line are always concentrated at the center of the waveguide. Then the resistive rotary 1A attenuator provides the precision attenuation with an energy of plus or minus 2.1% of indicated attenuation over the operating frequency range, and it consists of three 1As. The central 1A rotating type placed in the central section of circular waveguide, arrangement tapered at both the ends. When all three 1A are assigned their planes at 90 degree to the direction of E, so there is no attenuation. So this figure shows the mobile attenuator with the dielectric rods. Then some of the questions are: explain with neat sketch a precision type variable attenuator. Explain with neat sketch a flap type variable attenuator. Explain with neat sketch the precision resistive type of attenuators. Some of the multiple choice questions are: first one, the variable attenuator exhibits variable attenuation but constant input impedance and the output impedance. Then which type of attenuator provides a fixed amount of attenuation by allowing user to vary the attenuation in multiple steps, that is ladder attenuator. And third one, a piston attenuator is a waveguide below cutoff. Then why are the variable attenuators applicable for radio broadcasting purposes in order to control the volume? Then for conclusion part of this chapter, that is, from this we come to know that what is attenuators and what are the types of attenuators, that is a fixed type of attenuators and variable type of attenuators. Also the variable type of attenuators having two attenuators, that is flap attenuators and the mobile 1A attenuators. Thank you.